I'm Mr. McBrien. This is TEJ3M, Intro to the Arduino in class version. So, in order to begin talking about the Arduino, I'd like to talk about how a computer, whether it's a PC, an Apple, or an Android, communicates with the outside world. And I'd invite you to pause the movie. I know we just started. Pause the movie and think about how this happens. Okay, welcome back. So in terms of how a computer communicates with the outside world, I would think that you probably thought in terms of mice and keyboards, in terms of the getting data from the outside world. Maybe you thought about the internet as a data source, maybe something else. And in terms of output, I suspect you mainly thought about the monitor, maybe you thought about audio as well, those kinds of things. Now, I'd invite you to think about the idea of what you would have to do with a computer if you wanted to send or to receive just a simple electrical signal. Just that potential that we talked about in our circuits. If you wanted to read a potential coming from a device, or you wanted to push out, for example, a potential to an LED bulb, well, that's actually a very challenging thing. So computers don't do a very good job of communicating those simple outputs. Instead, they're carefully defined in terms of the way that they connect with other devices. It's really quite challenging to have a PC directly control an alarm system, for example, or to control a robot. So it seems that the simpler the interactions between devices, the harder it is for a PC to work effectively. We need things like device drivers and things to communicate, and we just don't have those for a simple electrical signal. So the Arduino, one facet of it is to address these problems. It also addresses a large number of other problems that we'll talk about soon. Okay, so for today we're going to talk about the Arduino. We're going to go through some example projects. We'll talk about a first sketch working either with Tinkercad or in class. So first off, what is the Arduino? It's an open source microprocessor platform. So we can think of it as a small computer that is in fact open source. It has great versatility in terms of controlling and reading electronics. It can be programmed easily using an integrated development environment. And while it is simple, it can be extended in terms of other hardware, what we call shields, circuit boards that we clip onto the top of the Arduino, giving it additional power where we need it. It's customizable. And it connects up to the computer as well as to breadboards through what are really quite simple connections. So let's talk about them here. So this is an Arduino Uno. This is the least expensive and simplest of the Arduino flavors. It has an input for a DC power jack. It has an onboard processor with a small amount of memory. It has a USB jack for connecting up to a computer. And it has some familiar looking little holes in the top that look just like a breadboard. And in fact, they're used in just this manner. So it has input pins to read electrical signals, and it has output pins to push out electrical signals. So small amounts of current can be sent out by it, and small potentials can be read by its systems. So what can we do with this crazy thing? Well, in fact, there's a lot we can accomplish with this device. It has a tremendous versatility to it. So I combed the internet and found a couple of fun projects to illustrate things. This, in fact, is a secret knock detector. So it was implemented to unlock a door automatically when it heard the appropriate pattern of a knock on the door. And this can work quite effectively. I had a student make a lockbox that would only open if you use the secret knock. Quite a clever implementation. Now in this case, the Arduino was configured to connect to the internet, read Twitter feeds, and based on the sum of the world's Twitter outputs, use a color-coded LED bulb to try to determine how the world is feeling. I'm not sure we want to know what color it would be at this point in history. A little bit of a closer to a traditional implementation. Here is an eye writer that watches the operator's eyes and types on a standard computer keyboard based on the position of the operator's eyes, allowing you to type without hands. All right, so there's some clever implementations. How do we set this thing up? Well, we wire the Arduino much like we've been wiring our circuit projects with some simple jumper cables. Now, we will, when we want to build permanent implementations, we'll tend to create our own shields to clip onto the Arduino board so that they're a little tougher and can take a bit of a bashing around. But for our temporary implementations, we'll usually just use a standard breadboard with jumper cables, just like we did through the last unit. When we want to program the Arduino, we can install the IDE on various computer platforms. And there's also an online compiler, the Arduino web editor. And then once we've created our program, we can push the compiled code to the Arduino for execution through a USB cable. Now this USB interface is very handy because, as we learned at the beginning of the course, USB can provide 5-volt power. And the Arduino will happily run using that 5-volt output from the USB cable. Now, I alluded briefly to the idea that an Arduino is nice and portable, that it can be put into movable devices. So what about that USB cable? Well, I've noted that a lot of students have the misconception that the Arduino is connected to the PC and the PC is actually controlling the device. And nothing could be further from the truth. In fact, as soon as you've created your code, the Arduino can execute that code, read inputs, create outputs as you need it to, without being connected to any kind of other processing power. The only thing you have to do is provide it with batteries. So the Arduino is extensible. You can have hardware shields that clip onto the Arduino, and there are a huge number of these available. You can equip the Arduino with Wi-Fi if you need internet connection. If you want a wired connection, there's an Ethernet shield. If you need to be able to control large amounts of current for motors, there's motor controllers. If you want to create a remote control device, you can implement Bluetooth. Much more is possible. Now, if you don't have hardware available to you, if you want to work on projects at home or what have you, there's also a virtual Arduino available through Tinkercad. So their circuit simulator will support Arduino programs. So you can start to build more complicated circuits now, code inside the Tinkercad interface, and send your code to your virtual circuits, allowing you to execute control of NeoPixel LEDs in this case, or what have you, and seeing what your program will look like. So you can, if you're ordering parts and waiting for them to arrive, you can develop your code and test it in a virtual environment. There's a lot of resources available to you in order to develop your sketches for Arduino. You can, of course, use my slides as the classes proceed. There's a wonderful booklet that is in Classroom right now and freely available online. The Arduino website contains huge amounts of resources and example code to help you get started. And when you get stuck, the Arduino forum has a wonderful FAQ and amazing people online to help you as well. So there is just a tremendous amount of material available to help you become effective with the Arduino. Now, in terms of how you're going to do well in this programming unit, we will be evaluating projects. Teams of up to 2 can create them. You're going to work your way through our booklet, completing as many of the activities as you can, and your submissions will take the form of a movie of the device functioning, a screen capture that clearly shows the circuits working, as well as making sure that you have the commented code submitted. So all of those things will be evaluated. Be aware that every activity has a standard configuration that's quite easy to put together because it's very well documented, and then a custom configuration that you need to make some modifications of your own. This is to encourage you to understand what the code is doing. Your evaluation, 50% of it will just be based on does it work? About 25% is on the proper communication. So is it properly commented and laid out? And about 25% will be for the hardware aspect of it, the device design, whether the wires are tidy, etc. So for your homework today, please install the IDE if you're going to be using that. Review the activity booklet, and then go ahead and build the system and install the simple blink circuit. Once you've done that, you can go ahead and modify the code so that your LED will stay off for 250 milliseconds, a quarter of a second, and on for 500 milliseconds, half a second. And once you've done that, you're done for the day. Thanks very much. Have a great night.